Hello, welcome to Quantum Online Academy. This is your Dr. Nagaraju Pendam. Today in this video we are discussing about very wonderful equipment, that is telescope. The telescope can detect the ghost particles. What are the ghost particles? Why scientists need this telescope? Where installed these telescopes? We have to learn in this video. So, once again going to enter into this video, please share and subscribe our Quantum Online Academy YouTube channel. Thank you so much. Now, you have to see underwater telescopes to detect the ghost particles. Underwater telescopes, these telescopes are there within the water, so they are keeping to detect the which one they are want to detect ghost particles. What are the ghost particles? Once we have to see, ghost particles is nothing but neutrino particles. So once you have to see why scientists are installing underwater telescopes to detect the ghost particle. Why scientists are installing underwater telescopes to detect the ghost particles. So these telescopes are much like ice cube neutrino observatory. There is a ice cube neutrino observatory is there. Ice cream neutrino observatory. This ice cream neutrino observatory which can detect the high energy neutrinos from deep space, but it is under the frozen ice in Antarctica rather than being in the water. So rather than being in the water, this ice cube neutrino observatory, they kept under the frozen ice. They kept under where? They kept under the frozen ice to detect whom? To detect the ghost particles. Ghost particles means neutrinos. Neutrinos, these are the second abundant particles in the universe. The first abundant particle is the photon. So these are the fundamental particles, because in the fundamental particles there is a subparticles are there. The subparticle belongs to the neutrino particle. Once again you have to see why scientists are installing underwater telescopes to detect the ghost particles, that are neutrinos. These telescopes are much like the ice cube neutrino observatory. In 2015 UPSC exam people, UPSC prelims exam, there is a question came, so based on the ice cube neutrino observatory. Based on the ice cube neutrino observatory in 2015 prelims exam, there is a question belongs to this one. So that's why this is advanced telescope. You have to concentrate on this. These telescopes are much like a ice cube neutrino observatory which can detect high energy neutrinos from deep space. What is the deep space? The space above the earth atmosphere. The space above the earth atmosphere. The space above the earth atmosphere, that space we call it as a deep space, but it is under the frozen ice in the Antarctica. This ice cube neutrino observatory is there in Antarctica to detect the neutrinos rather than in water. But now the scientists are kept in the water. Now the scientists are deploying two telescopes, not one telescope. Two telescopes are deploying. The scientists are deploying two telescopes to detect a high energy neutrinos. The aim is the same, to detect a high energy neutrinos. These neutrinos we also call it as a ghost particles. Which particles? These neutrinos we also call it as a ghost particles under the Mediterranean Sea. First telescope is there concerning to detect the neutrinos. There is a high energy neutrino telescope. The telescope was in Antarctic continent under the frozen ice to detect the high energy neutrinos. The scientists kept one telescope. That telescope is ice cube neutrino observatory. But now scientists are deploying two telescopes to detect the high energy neutrinos, also known as the ghost particles, under the Mediterranean Sea, under water they kept these two telescopes. So the two telescopes are part of the cubic kilometer neutrino telescopes. These telescopes we call it as a cubic kilometer neutrino telescopes, cubic kilometer neutrino telescopes, KM3NET, cubic kilometer neutrino telescopes. While one of the telescopes will study high energy neutrinos from space, one telescope will study high energy neutrinos from space. From space means that is the deep space, from deep space above the earth, and from above the earth atmosphere surface. Deep space means above the earth atmosphere surface, we call it as the deep space. One telescope will study high energy neutrinos from deep space, the other will examine neutrinos from the atmosphere, neutrinos from our earth atmosphere, not above our earth atmosphere neutrinos can study. This is the main objective of the telescopes. Two telescopes are scientists installed under the Meridian Sea. These telescopes to detect the ghost particle. What are the ghost particle? High energy neutrinos particle. Clear? Now, what are neutrinos? Maybe physics people can know the neutrinos. Particle physics, this is a particle physics curriculum, but out of the physics people there is a curiosity, what is the ghost particle, how it works, why scientists need to research to detect the neutrinos, that is main important, no? So that is why you have to see what are neutrinos. Detected from first time in 1959, neutrinos were detected, but through their existence was predicted almost 3 decades earlier in 1939. In 1939 only these neutrinos was predicted, but even though these neutrinos were detected in 1959, neutrinos are tiny particles very similar to the electrons. These neutrinos are, we have to symbol like this, this is the neutrinos. Neutrinos are tiny particles, so very similar to this electron, but electron has the charge, electron have charge, but neutrino does not charge. So neutrino does not have charge, neutrino does not charge, but electron is the charged particle. That is the difference once you have to see. Neutrinos are very tiny particles, a small particle, even though we can't see with our naked eye because it is a sub-fundamental particle, very similar to the electrons, but without any electrical charge. There is no electrical charge, that is very, very important. Neutrino have no electrical charge. They are one of the fundamental particles the universe built of, or the second most abundant subatomic particle. This is the second most abundant subatomic particles after the photons. After the photons, so what are the second most fundamental particle? The second most fundamental particle is neutrino. Second most fundamental particle in our universe, that is neutrino. Neutrinos are so numerous that about 1 billion of them pass through a cubic centimeter of space every second. In every second, once you have to see, in every second neutrinos are so numerous that about 1 billion of them, suppose you have to see, I am a person, every second there is a millions of neutrinos pass through our human body. So that is why we want to discover how the photons are there available in our universe. Similarly, neutrinos also available in our universe. So that is why it is very, very interesting phenomena to detect the neutrinos. Clear? So once again you have to see, why do scientists want to study high energy neutrinos? Scientists are interested in examining super fast, these are super fast high energy neutrinos. that have come from far and far away. Such neutrinos are rare or mostly originate from exotic events such as a supernova and gamma ray bursts and colliding stars. These neutrinos originate from where? Supernova, gamma ray bursts, colliding stars. From these neutrinos are generating. Studying high energy neutrinos can help astrophysicists investigate those space mechanisms and regions like the center of Milky Way galaxy. To study the Milky Way of galaxy, these neutrinos we want to detect are shrouded in dust. Dust absorbs and scatters the visible light from objects, making them difficult to impossible observe with optical telescope. Through optical telescopes, we can't observe these neutrinos. That's why we have to inbuilt this one. In 2022, one interview conducted Cosmos magazine conducted one interview in their Elisa Resicconi and astrophysics at the Technical University of Munich, Germany, said with neutrinos we can study beyond any dense cloud or accretion disk or beyond any dense cloud we can study is very important. In 2022 one Cosmos magazine gave one interview. So take one interview from Elisa Resicconi, is a astrophysicist at the Technical University of Munich, Germany, said with neutrinos we can study beyond any dense cloud or accretion disk. Not only this, high energy neutrinos can also give clues about the cosmic ray production or even dark matter. We can find out about the dark matter clues, cosmic ray production clues. Discovery something we cannot imagine today. We understand only a very small fraction of the universe. So if you have to understand about the neutrinos, we can reveal about the universal things, we can reveal about the undiscovered things whichever there in the universe. Those things we have to deliver. Not only those dark matter thing we have to deliver, how the cosmic ray produced we have to deliver, and beyond the dense cloud how many things are there, those things also we have to reveal by using this. Which one it is? That is the neutrino detection. That's why the scientists are eagerly interested to discover the neutrinos. Why are scientists building underwater neutrino telescope? Why they build underwater? That is also major question. In space, so much of space is there, and in the mountain also we have to build. Why the scientists built underwater? That is already in ice they built. Cube ice observatory, neutrino observatory was there already in Antarctic, but now they built in underwater. Why? So that's once you have to see. High energy neutrinos, however, are not just rare but also extremely difficult to detect. One reason is that neutrinos barely interact with anything despite billions of neutrinos around us. In billions of, within a second, a million or billions of neutrinos are passing around us. So an average of only about one of them will interact with a person's body during the lifetime. So billions of neutrinos around us, an average of only about one of them will interact, only about one of them will interact with a person's body during a lifetime. During the lifetime, only one of them, in among the billions of neutrinos, only one of them will interact with a person's body during a lifetime. That's why we have to kept it under the water. Even the ice cube neutrino observatory, which has been operational since 2011 and was the first telescope to detect the high energy neutrinos, has been able to only spot handful of these messengers. So that's why to detect high energy neutrinos, there is a need for a large volume of optically transparent material. They need a large volume of optically transparent material in place where it is extremely dark. The highly optically transparent material is available under the sea only. So that's why the location needs to be dark, because the detectors look for flashes of Cherenkov radiation. Which radiation it is? The flashes of Cherenkov radiation, light that neutrinos produce when they interact with the water or ice molecules, according to report by Cosmos magazine. So where from I took? From Cosmos magazine I took. That's why under the water there is a dark place is there. Within the dark place there is a optically transparent material is water. Water can detect. So how the neutrinos can interact with the water molecules, we able to find out using these telescopes. That is our ultimate goal. The flashes help scientists to trace the path of that neutrino, giving them details about its source, the amount of energy it contains and its origins. Because of the when the neutrino interact with the water molecule, we have to come to know about the what is that energy, how the interaction takes place, while interacting takes place, what energy is releasing, water molecule can takes place anything or not, we have to discuss based on those telescope observations. Although both frozen ice and deep sea waters provide a conducive conditions for detecting the high energy neutrinos, experts suggest that underwater neutrino telescopes could be more efficient than the ice cube. Underwater neutrino telescopes are more efficient than the ice cube. That's why scientists build in underwater telescopes to detect the ghost particles. So that is because water scatters light less, so which gives a more accurate idea about where the detected neutrinos came from. So the one disadvantage is that water absorbs the light also more. As a result, there will be less light to examine. There will be a less light to be examined because water absorbs the light. One disadvantage also is there. This is very important. In this video, we discussed about the ghost particle detection. Ghost particle is the neutrino particle. It does not have the charge. It is a subatomic particle. It is second abundant particle in the universe. So please remember where two telescopes were deployed under the sea in Mediterranean Sea, right? This one you have to remember. This is very important topic. The compulsory you have to write the high level competitive exam, UPSC, like that high level competitive exam. There is a scope to ask the questions based on this. Already in 2015 this question came when this constructed the ice cube frozen neutrino observatory in 2011. In 2011 they installed it. In 2015 UPSC they are asking the question. So that's why question whenever they will ask, we too don't know. So you able to practice it and you able to remember and you able to recognize the things. Thank you so much. Please share and subscribe our YouTube channel to your friends. Thank you.